All right, boys and girls, we're going to be doing section 5.3, which is graphing cubic functions. This is very similar to the very first lesson we did, okay? So the essential question basically asks, how are the graphs f of x equals a times the quantity of x minus h cubed plus k related to the graph of f of x equals x cubed? All right, a couple things you need to know. This, you need to know this formula and please memorize it, okay? It is our cubic function, and it's written in vertex form. Okay, remember that. This is vertex form, and it's our cubic function. And the reason why it's vertex form, because just like in quadratic, our vertex is HK. Okay, so remember that as well. Okay, and then the reason why they want you to relate it to x cubed is just like before, this is your parent function, okay? So this is the parent function. This is the original, okay? We're going to compare everything to the original. All right, awesome. So you can just read that on your own. I would say the important part here would be this part, which I already let you know. So this is part of the cubic, okay? So here we go. Right here, they want you to complete the table, and this is for the parent function. Okay, you can grab a calculator if you want, or you can just do mental math for this, okay? Which is what I'm going to do. So this is negative 2 cubed. If you do a calculator, don't forget to put parentheses. So it should look like this, okay? Now, you're going to see whether you put parentheses or not, that it makes a difference, okay? So negative 2 cubed is the same as saying negative 2 times negative 2 times negative 2, okay? But if you put parentheses, it'll give you negative 8, okay? And if you don't put parentheses, guess what? It still gives you negative 8. And the reason being is because a negative times a negative times a negative is still a negative, okay? But I just get students to get in the habit of doing it because they forget when it comes to the square. And then for the square, it makes a difference. And I mentioned that before, okay? Anyways, negative 1 cubed will give you negative 1. And of course, 0 cubed will just give you 0. 1 cubed is just 1. And then 2 cubed is 8. Notice I didn't put parentheses in these, and that's because they're positive, so it doesn't matter. Positive times a positive times a positive is still going to give you a positive. All right, now we're going to graph it. So negative 2 and negative 8. So that's my first point. Negative 1 and negative 1. 0, 0. And 1, 1. And 2, 8. I'm going to use a red pen just so you could see it, okay? A couple of things you should notice. This is your vertex right here, okay? That's your vertex, and your vertex is at 0, 0. So it's right there. As a matter of fact, a couple things. Students always have a hard time drawing these, but I tell them, look, on one side of the vertex, on the left side, it's going down. So I tell them, just draw it like half a parabola. And then on this side, it's going up. So you're drawing like kind of like half parabola. And this is the point where it changes. So it goes, ignore the arrow here, but it's going, because remember, we read graphs from left to right, just like we read a book, okay? It's going up, and then at this point, that's where it switches. And then it goes straight up, okay? Now, I know it looks like it's going down here, but ignore that. Just up and then up, okay? Or you can think of it, I guess, as a negative and then a positive, okay? All right, so moving on to the next part. Actually, I wanted to make one more point. It has to have a curve, okay? So, again, see how I kind of curved it here? They shouldn't be like... they shouldn't be sharp points. So make sure you curve it. So I think just kind of drawing like half a U down, half a U going up. I think that makes more sense. So start at the center and then go down, and then start at the center and then move up. Okay. right, so now we're going to move to the table down here. We're going to fill this out, okay? So whenever we talk about domain values, we're looking at our X values, okay? So if you notice, we made a chart and we picked 5 points. And by the way, these 5 points, I usually call these my Fab 5, okay? Two negatives, 0, and 2 positives, and it's -2, -1, and then 1, 2. Okay, these are the Fab 5 that I always graph. So I could have plotted way more X's and way more like positive and negative values. And I wouldn't have stopped, because if you notice, your graph is going to keep going. So the further it keeps going here, the more X's I'm choosing. And the further it goes up, the more X's I'm choosing. So what that means is there's no restriction in your domain. So see the symbol right here? It actually looks like this. If you were to write it, it looks like this. Kind of like two lines and then like an R, or a line and then an R. What this means is all real numbers. Okay, all real numbers. It just means there's no restriction. I can keep going. I can pick as many X's as I want on either side, X and Y. Okay. Now, when it comes to your range, you should be looking at your Y values. So you're looking at it up and down. Notice both ends of my graph have arrowheads going down and up. That means it's going to keep going down. How far down? All the way to negative infinity. It won't stop. This is going to go up all the way to positive infinity. It will not stop. So for your range, guess what? It's also all real numbers. Okay, so they're the same. Now, just a little FYI, you can write it in words, all real numbers, or you can just put the symbol. Okay, as soon as you see the symbol, we know that it's all real numbers. So either one is okay for me. Okay, now let's talk about end behavior. End behavior is literally like the ends of your graph, okay? So this is how you read it. As X approaches positive infinity, f of X approaches. Think of f of X as your Y, okay? So now look at your graph. As X approaches positive infinity, you're going to split your graph basically into 2 parts, the left side and the right side. The left side of my y-axis are negative X values. The right side of my y-axis are positive X values. So since X approaches positive infinity, we should be looking at the right side. You're going to tell me where your y's go. And remember, y's are up or down. So I'm going to cover this side. As X approaches positive infinity, where does my graph go? My graph moves up. How far up? Because it never stops, right? All the way to positive infinity. So in here, I would put positive infinity. Then we're looking as X approaches negative infinity. So now we look at the left side of the graph. As X approaches negative infinity, where does my graph go? My graph goes down. How far down? Negative infinity. All right. Awesome. Okay, zeros of the function. This is another word for roots or x-intercepts. Hopefully, x-intercepts, sorry. Basically, where does it cross the x-axis? So you should be looking at your x-axis. What's the only point that it crosses the x-axis? And that's at 0. So it's when x equals 0. Okay, so zeros are your roots or your x-intercepts. So you should have an x value, and that's 0. Okay, now it says where the function has positive values. Where does the function have positive values? The further you go to the right, or the further you go to the right of 0, you're going to have positive values, right? So x is greater than 0. Where does the function have negative values? Well, that's kind of the opposite. The further you go to the left, you're going to have negative values. So this is x is less than 0. You can't say equal to 0 because at 0 is just 0. That's not positive nor negative, okay? All right, where the function is increasing. Where is the function increasing? Well, you have to think. Earlier I said you read a graph like you read a book from left to right. So ignoring this, the further you go this way, because again, you're reading it like you read a book. The further you go over here to the right, what's happening to your graph? It keeps moving up. So guess what? This graph is always increasing because then it's going to keep going up. So the graph is always increasing. And notice I said the graph is always increasing. So the next question says where the function is decreasing. Well, the function never decreases. It would be an oxymoron to say the graph is always increasing and then to say, well, it's decreasing here. No, because I use the word always. Okay, so it never decreases. Okay, and then the last part says if the function is even, f of negative x equals f of x, odd, f of negative x equals negative f of x, or neither. Well, we've actually talked about this in the previous section in 5.1. If you recall, if you plug in a negative value, will you get, for example, we talked about like if x was 2 and if x was negative 2, if you recall, whether you plug in a positive or a negative, when is it even versus odd or neither? You actually did that in the last section, if you recall, right? So remember, if you plug in a positive and a negative and your values come out to be the same, that's even. If you plug in a positive and a negative and they're opposites of each other, meaning same value, but one's positive, one's negative, then they're odd. And neither would be if you plug them in and you get two different values. So go up to your table and notice when we plug in negative 2, we get negative 8. When we plug in positive 2, we get positive 8. So same values, it's just one's negative, one's positive. Therefore, this is going to be an odd because x cubed will give us negative x cubed. Okay, so symmetric through the origin. I'm going to write that down. Symmetric. Oops, sorry, moved my camera. Through the origin. Okay, remember if your vertex is right at the y-axis, then it'll be symmetrical. Okay, that's another hint visually. Okay, all right, guys, awesome. Well, let's get started. Okay, so today we're just going to get as far as example 1, and I'm basically going to show you how to graph and describe, and that's it. Okay, so example 1 says describe how to transform f of x, x cubed to obtain the graph of the related function of g of x, then draw the graph of g of x. Okay, awesome. All right, here we go. We have our function g of x equals 2 times the quantity of x minus 1 cubed minus 1. To be honest, the first thing I would do is write the vertex form right above. Okay, so this is a x minus h cubed plus k. Okay, and until you have it memorized, then I would stop, I guess, but it doesn't hurt to write it down. Okay, so just like in 5.1, your a value will either tell you if it's for vertical compression or if it's a vertical stretch. Okay, remember your vertex is hk, just like before, and your h value will tell you if it translates left or right, and your k value will tell you if it translates up or down. Okay, all right, so real quick, let's write these down. So we need our a, our h, and our k. And I'm going to use pencil in case I make a mistake, okay? A is 2, and it's a positive 2. So what that means is we know it's not going to be flipped. It just stays the same, but it is greater than 1. So what's going to happen is this is a vertical stretch, okay? H, notice our negatives are the same. That means H is 1. If you recall in the previous, I kind of gave you a hint, whatever h is here, just give me the opposite. So here it looks like it's -1, just give me 1 because there's already a minus there, okay? That means it's going to translate it 1 unit to the right. 1 unit to the right. Okay, and then k is just -1. That means it's going to be, it translates 1 unit down. All right, guys, so this is what you know. This is how it's transformed. And what they did there is they actually graphed the parent, okay? So now all you have to do is plot this one, okay? So I'm going to show you the same way we did last time. So I'm going to draw a quick table, XY, and I'm going to use, I'm going to go ahead and use 5 points. So 1, 2, 3, 4, 5. Okay, and then my very first point that I'm going to plot is our vertex, and our vertex is HK, so that's going to be 1, -1, and I put that right in the middle, okay? That's our vertex. And then that kind of gives me an idea of what other points to plot. So I'm going to move to the left. So moving to the left, I'm going to put 0 and then -1, and then I'm going to move to the right, so 2 and 3, okay? And then basically just plug them in and work it out. Okay, so I'm going to show you one, and then I'm going to show you kind of a quick way of doing this. Okay, so I have a graphing calculator. You can use Desmos as well. So notice I have 2. My x is going to be, let's try with -1. -1 minus 1, and then it's going to be cube. And then move my cursor plus oh, I'm sorry, -1. I was lost for a minute. Okay, so this is what it looks like so far. Okay, then press enter and I get -17. Okay, let me use a pencil, -17. If you have one of these calculators, either you download it on your phone or you just have one, then you could just press second and enter, and it'll give you everything, and then you just move your cursor and then change your x to 0, and then that'll give you -3. Okay, all right, and you can just kind of keep doing that and solving the other ones. But if you have one of these calculators, either you downloaded like I said, then here's another hint. You can press y equals and make sure there's nothing in here, and then you can actually plug in that equation. So I'm going to do that just to show you an alternative. Okay, so I'm going to put 2 parentheses x minus 1 to the 3rd power minus 1. And then instead of me pressing graph, which I could because it'll show me what it looks like, I'm going to put second and graph, and I'm going to go straight to the table. Okay. And then it's going to give me a table which gives me all the values that I need right away. See? So -1 is -17. 0 is -3, 1 is -1, and 2 is 1, and 3 is 15. Okay, and it gives me a quick way of giving me my values. Okay, now the other thing is we are going to graph this. We're going to plot these, and then if you look at the table that or the graph that they gave you, they didn't give you a lot of points. As a matter of fact, your y's only go up to 6 and go down maybe to 3. So believe it or not, you don't need 5 points to graph because you're not going to be able to plot those. So all you need is 3, and that's okay. You're either going to plot 3 points or 5 points, okay? Or sometimes 4. So all we have to do is plot these 3 points, okay? So here we go. 0, -3. So it's going to be here. 1, -1. And 2, 1. Okay? And then again, some people think, oh my gosh, I'm going to draw a line. No, be careful. Go to your vertex and then just draw half a parabola going down and then draw half a parabola going up, okay? And make sure you curve it, okay? This is what it looks like. And here's the nice thing. If you have a graphing calculator, now you could just press graph And if you're not sure you're drawing the right thing, then it'll show you the graph. And this is what it looks like. Okay. All right, awesome. Let's do one more together. So anyways, I encourage you to use one of these or Desmos or download it onto your phone. All right, boys and girls, now we're going to move on to example B. And then our equation is g of x equals 2 times the quantity of x plus 3 cubed plus 4, okay? And then as I was writing this down, I realized that on the top, I put squared instead of cube, and I apologize. It should have been cube, okay? All right, so let's identify our values, a, h, and k, okay? According to this, a is 2, h is -3, and k is 4. Remember, the only value that is going to be the opposite is your h, okay? Because it's negative, so they must have plugged in a -3 and then came out with a positive, okay? All right, since a is 2 and it's greater than 1, then basically you're going to have a vertical stretch, okay? And h is -3, that means it gets translated 3 units left, okay? K is 4, so this time it gets translated 4 units up, okay? All right, so if you're wondering, why do we have to write this? Believe it or not, this kind of gives you a visual in your head as far as how to, what it's going to look like, okay? All right, so now we're going to plot it. We're going to graph it. So I'm going to start by writing down my, my vertex. So my vertex is -3, 4. And if you want, you can plot it over here now. So -3 would be here and +4 would be here. So most likely it's going to do something like this. Okay. Now, does this make sense? Look, it moved to the left 3 units, 1, 2, 3, and then it moved up 4 units. So from here, it moved up 1, 2, 3, 4. Okay. So if this is the vertex, the old vertex from the parent, 1, 2, 3 to the left, 1, 2, 3, 4 up. Okay. So that's how we use this information. All right, so let's come up with our values. Again, I'm going to pick points to the left. So it's going to be -2, -1, and points to the right. So now I'm going to choose -4 and -5. Okay. Or I kind of have it flip-flopped. These go to the right and these go to the left. Okay. Anyways, if you plug in -2, it'll give you 6. If you plug in -4, it will give you 2. And these values here are way too big to plot. Again, just figure out, use your calculator, but -1 will give you 20 and -5 will give you -12. So obviously it's way too big for my my graph. So I already know I'm just going to plot these. Okay, so my 3 points that I'm plotting are -2, 6, and -4, 2. Okay, so this is what it looks like. Okay, guys, again, whenever I have students plot these, they forget and they want to draw a line right away. But remember, you have a reference here to look at, so you know what it should look like. And if you forget, just look at your calculator, okay? So remember, this is not a line. And that's the unfortunate part when you only graph 3 points, but you know, this is what it looks like. So start at the vertex and just kind of curve like half a U. And then same thing, curve it, okay? And then this is what it looks like. All right. Okay, awesome. So there's one more. Okay, so now I have the your turn. Go ahead and pause the video, work it out, graph it, and then come back and check your answer. All right, boys and girls, hopefully you did it correct, and this is what you should have gotten. A is -1/2, which means because of that negative, it gets reflected across the x-axis, okay? Oops, you know what? I put x-axis and it doesn't get flipped this way this time. It gets reflected this way, okay? So I apologize. I was in a hurry and I wrote x-axis, y-axis. So it gets reflected this way, okay? so you can tell the reflection. This time your mirror is on the y-axis, okay? So I apologize for that. So negative, okay? Then this time it's a vertical compression because A is smaller than 1. So it's 1/2, ignoring the negative. Remember, we want the absolute value. So vertical compression. And then H is 3, so it gets translated 3 units to the right, okay? Since K is 0, that means it didn't move up or down, okay? And again, you can check. This is the parent vertex. So it basically got moved 3 units to the right. So, oops, sorry, this one. 1, 2, 3. Sorry, I was pointing at the wrong one. This one, just move 3 units to the right, okay? All right, and by the way, since K is 0, nothing happened, you don't have to write anything. You could just leave it blank. I just wanted to write that down. This is the only change that occurred. And then here's your table. Notice I went from, this is your vertex. I went from 3 to 1 and I skipped 2. And I went from 3 to 5 and I skipped 4. That's because when I checked my answers, I got decimals and I didn't want to graph decimals. Now you could if you want, but I didn't. So all I need is at least 3 points to graph. If you can plot more, that's awesome. But if you can only plot 3, then that's fine. That's good enough. So I have my vertex and then my other 2 points and then a curve going down and a curve going up. Okay. And that's it, guys. That's all you need for today's lesson, okay? So we will continue this tomorrow, and I will show you the second part tomorrow. But for now, you have enough to do your classwork, okay? Or your homework. So get started, and if you need help, please reach out.